So the project that we had, or we have still, which is the industrial project. If you guys remember, there's a class 1 div 1 location, flammable gases. And so we need to install certain power system in certain ways in hazardous location. I know probably the ones who came from electrical, they heard the hazardous location before. You probably, Derek, I don't think you guys touched on hazardous location. What happened, guys, is the Smarter Than Your Friend Ch in any secret book take the most dangerous locations and they classify them in 3 classes. Cool. Based on the flammability and the fire and the explosions. And these 3 classes require, when you classify these areas based on 3 classes, it requires you to install certain power system in these classes in certain ways. More robust power system so you don't create explosions. So that's what this hazardous location is. A whole chapters, multiple articles, guys, related to hazardous location and the secret book. So let's go a little bit and talk about a few things how they classify them and what's not. So a few things that we're going to talk about, guys, is different classes. They talk about the classes and the divisions. We'll talk about classes and divisions and group of hazardous location. Adam, the room that we're in right now is non-classified location, which means you can use any approved wiring methods in this room. If it's a classified location, Karen, then you have to use special type of wiring methods. That's basically what we care about. That fixture here cannot be installed in hazardous location. Has to be a special type of fixture, special type of switches, special type of powers, cost you an arm and a leg. That's why we care about these. You'll see them in a second. There's something called, guys, intrinsically set circuits. These are electronic circuit, low voltage circuit that they use them because they don't create fire. And you'll see in a second. There's also seals that you have to seal for horizontal and vertical that they do in hazardous location. A good example of hazardous location, Matt, is gas stations. Gas station has flammable gases and vapors, right, and liquids there. So do you think you're going to go put a circuit breaker right in an area where it's flammable, and every time you turn that circuit breaker on and off or switch on and off, you create a big explosion in this gas station? So these areas, guys, they use special equipment for them, special equipment, special wiring methods. And then they have to have a seal. We'll talk about seal in a second. The equipment that they use, guys, they're explosion-proof equipment as well as cascaded luminaires, enclosed and cascaded luminaires. So to summarize the whole hazardous location, Karen, in a hazardous location, you have to pay a lot of attention to the type of equipment that you install in these locations. Done. You can't just put a receptacle and assume it's going to be a regular receptacle, guys, in these areas. They have to be a special type of receptacles. Otherwise, these receptacles or switches will create an explosion for you. Okay. Requirement for pendant luminaires. You have to put, if you want to put pendant luminaires, what type of requirement do you have to do? List of conditions for use of flexible cords in hazardous location. The requirement for flexible cords in hazardous location. So these are the things that we're going to be going over. So let's talk about the 3 locations that, guys, the any secret book classify as hazardous location, which means when you install a power system, Adam, in these locations, you are to pay a lot of attention to the type of material, the type of installation, the type of wiring in order to meet the code. The first one, guys, is class 1. Class 1 is 501. This is a 501. This is 502 in any secret book. This is 503. So 501, the areas that are classified as 501 has concentration of explosive gases, flammable explosive gases. Your gas station, your petroleum refineries, any place where you have gases that can ignite and explode. Natural gas, all the types of petroleum products, most of petroleum products will be under the explosive gases. So any place where you manufacture, process, deliver these gases, guys, it has to be classified as a class 1. Can I have any question, guys, about class 1 location, explosive and flammable gases and vapor? Everybody understand that one? So any location that has vapor or gas that can be, or liquid even, that can be explosive, flammable, ignite and explode, they classify as class 1. Class 2 is dust. Dust is flammable dust. Any location that you have a dust, a cloud of dust, guys, that's flammable, that could ignite and explode. This called explosive dust, or flammable or explosive dust. That's called class 2 dust locations. So any places that have chemical, there's a lot of chemical, guys. If you have a chemical that create a dust, chemical refiner create a dust, not a gas, not a vapor, and that cloud of dust can ignite and make an explosion, you're looking at a class 2 location. Class 3 location is fibers. Fibers, these are wood shops, all the places where they do, where paper mills, wood shops can be classified as a fiber, class 3 locations. So you're talking about wheat refineries, where the wheat mills, wood shops, like I said, paper mills, all these are class. They have fibers that can be combustible. It can ignite and explode. Any comments, guys? Any questions about these 3 locations? So who classifies them, Derek? The engineers and the architects and the fire marshal guys are the ones who classify these. So they walk into this area based on the gas or the dust or the fiber exists. They classify as class 1, class 2, and class 3. Who cares? The question would be, Karen, who cares about these classification? If it's class 1, you have to use certain wiring methods. If it's class 2, others, and class 3, a third wiring method. So the wiring methods will change. For example, in a class 1 div 1, I can't use EMT conduit even if I want to. Any comments, guys, about the classification? Class 1, class 2, and class 3. Can you have thumbs up, Chad? We know the difference between them. One is flammable gas, and the other one is ignitable dust and combustible fibers. Based on these locations, we classify them at 3 different locations. Why do we care? Because when you work for Parsons, right? Parsons. Now, when you guys are go bid on a place that has a refinery, that's going to cost you probably twice as much to install the same lighting fixture, receptacles, and air handling unit as if it wasn't an explosion or hazardous location. Do you guys see why it's important? Everybody understand why it's important? It's expensive equipment, expensive wiring methods that you have to use in these areas in order to prevent what? Fire and explosion. Your goal is to prevent fire and explosion. So these are the 3 locations. Then there's so the location. Then there's div 1 and div 2 division. They call it division 1, div number 1, and div number 2. Division 1, guys, the hazard exists at all times. Division number 2, the hazard exists under abnormal conditions. So you have a gas spill, that's abnormal condition. That's division 2. You have the hazard exists at all times, like inside the tank, the gas tank. I mean, do you want to put Riley switch inside the gas tank and ignite it? That hazard exists at all times. But around the gas tank, there is no hazard. But the hazard could exist under abnormal condition, which is division 2. Same thing for the dust. Same thing for the fiber. For the fiber, guys, the place where they process the paper is a class 3. And the place where they store these paper and fibers and wheat is a class 3 div 1, a class 3 div 2. So the storage area, the place where they store it here, is a div 2. It's lower hazard. Div 1 is a higher hazard. So every one of these classification is divided into 2. Div 1 is the higher hazard. Div 2 is the lower hazard. Does that make sense? Everybody understand the division? What's div 1? Div 1 hazard exists at all times inside the tank that has gas. Around the tank that has gas is div 2 because there's no gas around the tank unless you have a spill. Any comments about, guys, class 1, div 1, and div 2? Class 1, class 2, class 3, div 1, div 2. All of them have divs. So there's a div 1 here and a div 2 here. And also there's a div 1 here and a div 2 here. All of them have div 1, div 2. Div 1, the most hazard, div 2, the least hazard of that particular hazard. Okay, class location. In the classified location, guys, the equipment that you install cannot have exposed surface that operate at a greater temperature than that will ignite the surrounding gas. So that's the most important thing. When you put a fixture like this, the external temperature of that fixture cannot exceed the igniting temperature of the gas. Otherwise, you're going to have an explosion. That's the key when it comes to putting equipment in hazardous location. You can't have a temperature in a class 1 location in gases and vapors, you cannot put a switch or a circuit breaker or a fuse that will create heat on the surrounding that will reach the igniting temperature of that gas and make an explosion. That's number one. Number two, also, it doesn't allow the gas to enter the enclosures. So when you flip the switch and you start little arc, you have an explosion. So it seals the arcing and sparking equipment. It doesn't allow the gas and the vapor to get into it, number one. And number two, the surrounding gas doesn't get hot enough to ignite the boxes, does not get hot enough to ignite the surrounding. So that's your class 1 location. Same thing for class 2 location, guys. The equipment have a temperature that's not greater than what they listed here. They have a whole table that they say the equipment have to have certain temperature based on T rating of these equipment. So long story short, same thing in the dust. You want your equipment not to get hot enough in a dusty area that ignite the surrounding. That's it. So the equipment that they use, Derek, in a class 1 location called explosion proof. Explosion proof equipment have two functions. Number one, it doesn't allow the gas to get into it. Okay. And if it got into it, it doesn't allow, and there's an explosion inside it, it doesn't spread the explosion outside. Doesn't get the gas and ignite the whole area. And at the same time, the surrounding of the explosion proof box does not allow, the temperature does not get hot enough to ignite the surrounding as well. Then in a class 3 location, guys, they use a dust ignition proof. They call it dust ignition proof. Dust ignition proof, it doesn't allow the dust to get into it. It's sealed, bolted together, and it doesn't create a temperature around it the temperature of the equipment cannot reach an igniting temperature that can ignite the dust. Any comments, guys, about the equipment? Why it's so important for the equipment approval? So it's so explosion proof. The whole idea is not to ignite the dust, the fiber, or the gas. That's your area. In a class 3 location, the same thing, guys. The equipment cannot, the surface temperature cannot be greater than what's listed in these tables, which will give you a temperature limitation. Same thing, fiber. You have a fiber. Paper mills. You have all this paper and paper mills all over. Do you want to have the temperature get hot enough to ignite the paper mill and get it all in a big explosion? No. So the whole idea, guys, class 1, 2, and 3, guys, minimize igniting the flammable, the combustible, or the ignitable gases, vapors, or dust in these areas by giving it the temperature. How do you ignite things? Either by giving them a spark or by giving them a higher temperature, right? So they're going to starve these hazardous locations from their ignition, from ignition source. Any comments, guys? Any questions about the equipment? So when you put equipment in these areas, in the back of your mind, you have to starve that energy from a source of ignition by sealing the sparks, by not allowing the temperature to reach higher temperature to surround to increase it. Okay, groups. In a class 1 area, guys, they have groups. So A through E, these are the groups that they have. A through E, this is class 1, and then F through D, this is your class 2. So dust, basically. One of them is dust and one is gas. So look at this. A class A, group A, this particular gas is the most flammable. What you're looking at it, if in order to ignite it, all what you have to do is give it 581 Fahrenheit. That's not a lot. 581 degree Fahrenheit to ignite it. So that's not a lot. So you can see group A is the worst when it comes to ignition. So when you, like gases and natural gas and what's not, so what you need to do, guys, when you have a gas A, group A, then you have your equipment have to have a group A label on it. Not only explosion proof, not only class 1 Dev 1, but also group A. So what are the groups? The groups, guys, a list of material, gases, and vapors based on their ignitability. Being group A is the most ignitable, the one that you can easily ignite, and group D is the one that you need more energy to ignite it. Does that make sense? And A through E are gases, and vapors. F through G through D are dusts. Comments, questions? So based on this list of dusts and list of gases, guys, they can, hydrogen, for example, here's my hydrogen. Look at this, hydrogen is in group B. So you can see ethylene and a bunch of other gases. Trying to see if was propane is here. So anyway, so these are all the gases and the vapors that can be ignited, ignitable gas and vapors, grouped in groups based on their ignitability. Any comments, guys? Any questions about the groups? So when you guys install a system in a hazardous location, class 1 location, you need to ask first, is it class 1 div 1? Yeah. What type of a group material? Is it A, B, C, or D, A, B, C, E, and then for gases, and then F, G, and D for dust? Any comments, guys? Any questions about the groups? Groups. And you can see the temperature next to them is the temperature that needs to ignite it. So if you give that gas or dust this temperature, it will auto ignite. It will basically create a fire. And Derek, not you, not I don't classify these. The chemical engineers, guys, and petroleum engineers and all this stuff. Those are the guys, and the dust people, chemical people. They classify them based on their ignitability. There's a whole industry that does it. All what you need to do when you become an engineer, guys, and you work, and if you're working in hazardous locations, say what group of gas is this? So they have to tell you where does it fit in the groups. Is it A through? Is it E or A or E, or is it dust F or G, D? And based on this, your equipment have to be able to handle it. Okay, groups. There's something called intrinsically safe circuits and equipment. Intrinsically safe circuits and equipment, Adam, are sensors and instrumentations. These are low voltage equipment that they sense. For example, inside the gas tank, guys, you need to know what's the height of the gas inside that tank. You want to sense the gas height, the pressure. Okay, how are you going to sense these? The Smarter Than Ch designed something called intrinsically safe system. They're low voltage. They drain the energy from them, guys. So, for example, Derek, if you grab 2 hots of this circuit and you let them touch each other, you wouldn't get a spike. You would not get a spike. So, isn't that nice? So, you have a sensor inside the gas tank that does not spike. What does that mean if it doesn't spike? Means it's not going to get ignition. It's not going to give you an ignition. So these intrinsically safe system, guys, they use them for instrumentation and sensors and alarming systems inside the all the hazardous locations. So it can give you what's going on, temperature, pressure, all these sensors. Pick them up, and if they have a short circuit in that sensor, it wouldn't ignite. Does that make sense? So operate at low level energy that does not ignite. Do not contain enough electrical or thermal energy to cause the ignition. They don't ignite under abnormal, overload, or fault. So if you overload that circuit that goes to the sensor, it would not, doesn't have enough energy. Even if you short them, you grab a hot and a neutral and then touch them by each other, you wouldn't get an ignition. And then because of that, must be physically separated from all electrical circuits and are not so concerned. So you have to separate them from other circuits. You put them in a conduit, you mark them intrinsically safe system every 25 feet with a blue conduit, and you don't put anything in them. They're typically used for instrumentation. So they're used for instrumentation. Imagine there's a petroleum refinery. Can you imagine how many sensors are there to sense what's going on in that plant? If they have to put them, these sensors are not intrinsically safe system, they have to put them in rigid metal conduit and a lot of other things. So they created that system, which is a control system that doesn't have, you spark, it doesn't spark. So it gets you the sensor and it doesn't spark. Any comments about intrinsically safe system? Put them in a blue conduit, label them intrinsically system, separate them from all the other system, and they're used for sensing only, instrumentation and monitoring the system, monitoring what's going on in the system through instrumentation and signaling. So that's your intrinsically safe system. Okay, equipment. If you put equipment in hazardous location, guys, most of the wiring method have to be rigid metal conduit, threaded steel, intermediate metal conduit, MI cable. So in a hazardous location, Adam, class 1, div 1 and 2, can you use EMT conduit? No. MC cable? No. AC cable? No. You have to use special wiring methods, the most robust wiring methods, which is rigid, thick steel, conduit threaded, so the gas cannot get into them. You can thread them really good. Or MI cable, which is one of the most robust cables. Any comments, guys? Any question why it's so important to know the place that you're in hazardous location? You have to use the different wiring methods. Equipment. If you're using equipment in a class 1, div 1, it has to be explosion-proof equipment. Now, what is the explosion-proof equipment? If you get this picture in a class 1, div 1 location, it has to be explosion-proof, meaning it will, number one, the operating temperature of it will not exceed the igniting temperature for the gas, number one. Number two, it wouldn't allow the gas to get into it. Number three, if the gas got into it and have an explosion inside it, it will contain that explosion and would not spread it all over. Very, very expensive equipment. So if this fixture, Adam, above your head is $100, an explosion-proof one will be $500. So you try to avoid having explosion-proof equipment unless you have to. Okay, in a class 2 location, that's in a class 1, the gas. In the dust area, the equipment that they use is dust ignition proof. Dust ignition proof, guys, very simple. It doesn't allow the dust to get in. And also the accumulated dust around it, right? They have a panel like this. There will be accumulated dust on it. It would not ignite the accumulated dust. So it wouldn't get hot enough to ignite the dust that accumulated on these equipment. Any comments, guys, about the equipment that they use in these locations? One of them is explosion proof in a class 1, div 1, and typically div 2. In a class 2, div 1, they use something called dust ignition proof. So when you buy, and times dollar-wise, hard work, times it by 5. So if you need a panel like this, dust ignition proof panel, if this costs you $500, times this by 5 when it comes to ignition proof or explosion proof. Do you guys see why it's so important to pay attention to it in terms of estimating, Karen, and project management and managing a project in a hazardous location? Big deal. Okay, seals. What they do, guys, is they seal around the electrical equipment so the gas does not seep in. Look what they do. So here's my, this is non-hazardous location. This is a gas, natural gas in this area. Look at the explosion proof. Can you guys see the explosion proof equipment that you have right here? This is a panel. They have an explosion proof or a breaker panel. There's a controller, explosion proof controller. These are rigid conduits. They use rigid conduit. Then they use seals. Can you guys see all these seals? All these seals, what they do is a fitting and have an opening in it, and they put a seal. So if the gas is to seep somehow through this conduit, it will stop right here. It wouldn't be able to enter. Because if it enters the panel, what happens if you have a gas, natural gas inside a panel like this? Every time a circuit breaker turns on and off, boom, big explosion. Now the panel can handle it, right? But you lost the panel. So they want to minimize the explosion, so they put seals. So within 18 inches of every arcing and sparking equipment, guys, you have to have a seal. Motor, look at that, explosion-proof motor. So this can handle explosion inside it. And there's a seal within 18 inches of it. So everything that can create an arc, guys, like a circuit breaker, a switch, a magnetic contactor, anything that interrupt the power, generator, a motor, a transformer, they have to be explosion-proof and they have to be sealed around it. Any comments, guys? Any questions about sealing? You have to also seal every time you exit to a non-hazardous location. Within, I believe, 10 feet of that non-hazardous location, you have to seal. So you don't allow the gas to seep into different areas here. And, right? You're in a gas area, guys, gas and vapor, so, or dust. So you need to seal. There's a lot of sealing in these areas. To prevent sealing is to prevent the gas and the vapor and the dust from getting into the electrical equipment and create a fire. Okay, so here's my seal. So minimize the passage of gases. That's why we seal. They have available in standard conduit sizes and oversized too. You can put them vertical and horizontal. I showed you in a second. Vertical seals are designed. If you are doing them vertical, they have something called drain plugs. If you seal here, what happened to the condensated water? It's going to turn into water and sit right here and basically damage your equipment. So what they do is they have little holes that allow the water, guys, from condensation to seep. Get out. We don't want the water to seep. So they have something called drain plugs to avoid moisture inside the conduit. Drain seal fittings may contain weep holes. Some of them have weep holes to prevent the continuous drainage. So right here, gentlemen, in this area, so when you have a vertical, there will be a little bit of weep holes here. So if there's an accumulated water because of condensation, it will allow it to seep and get out. It wouldn't allow the gas to get in, but it will allow the water to move out. It's like a valve. Any comments, guys? Any questions about sealing? So sealing, you have to seal around arcing and sparking equipment like panels and circuit breakers and motors and what's not. Every time you exit, you have to seal within 18 inches of every piece of equipment that arc and spark you are to seal. Any comments, any questions? Seal is a big deal. You're going to see a couple of things later on, guys, about sealing. Okay, circuit breakers. Can you guys see this panel? Look at this. They have an explosion-proof panel, right? Look at this. This is exactly like this one, except it's 10 times more expensive. Could it handle an explosion? Okay, circuit breaker panels, explosion-proof in a class. If you put them in a class 1 div 1, it has to be explosion-proof. Type of enclosure determined by the atmosphere, the area that you're in, size of the breakers, and the number of breakers that you need, like any other panel. Panel suitable for in a class 2 location, gentlemen, you have to use ignition tight. Not permitted in areas containing hazardous gases or vapors. So if you have a panel like this in an explosion in a class 1 location, explosion proof. In a dusty area, ignition, they call them dust ignition proof equipment. You know what the manufacturers, guys, of these equipment will do, Derek? They have one piece of equipment because they don't want to split hair. And on the equipment, they say class 1, class 2, class 3, div 1 and div 2, and they list all the gases and the vapors and say, here, run with it. So that's how they do it, guys. They use one product that can meet all these requirements. Now, if you want to split hair and buy cheaper equipment, there are other manufacturers who can give you just ignition-proof equipment. That's it. I don't want explosion-proof, so cheaper. It will be a cheaper equipment. The most expensive one is going to be the explosion-proof equipment. The second expensive one is going to be the dust ignition-proof. The third one is called dust tight. Dust tight, guys, is just sealed a little bit that the dust cannot get into it. That's all. It could ignite the surrounding, but the dust. So it's thought explosion-proof more expensive. Ignition-proof, dust ignition-proof the second, and dust tight is the third in terms of how much you can pay. But you can't put dust tight in a class 1, a class 2 div 2. You have to have dust ignition proof in a class 2 div 1. So there's certain location. So long story short, if you have explosion proof equipment, man, you're good for most of these locations. Okay, so we got that one. The seals, drain sealings may contain weeps. Talked about these. Okay, luminaires. When you put luminaires, guys, in an explosion proof, a lot of them are enclosed. You look at enclosed and gas-kitted, vapor tight, but not explosion proof. If you put them in a gas area, you have to be explosion proof. If you put them in a class 1 div 1, the fixture have to be explosion proof. If you put them in a class 1 div 2, they don't have to be. They have to be vapor tight, enclosed, and gasketed. These are not permitted in a class 1 div 1 because they need to be explosion proof. Can be used in class 1 div 2. So guys, an explosion proof lighting fixture like this can be used anywhere. Now, but it's expensive. In order to make a cheaper piece of equipment, Derek, they have something called enclosed and gasketed fixture, which is cheaper. But you can't use it in a class 1 div 1. You have to use it only in class 1 div 2. So that's cheaper equipment. When a fluorescent type luminaires can also be obtained from hazardous location, permitted in class 1 and class 2 locations. So a lot of these guys, they can get incandescent or fluorescent fixture that you can use as explosion proof or enclosed and gasketed fixtures. Any comments, any questions about lighting fixtures? Karen, if you are to put a lighting fixture in explosion-proof location, it has to be explosion-proof. It's in a class 1 div 2, it has to be enclosed and gasketed. If it's in a dust location, it has to be dust ignition proof. In a class 1, in a class 2 div 1, and class 2 div 2, it can be enclosed and gasketed. So the type of equipment, you will look at them in a second. Fixtures, guys, have to be rated in temperature, so they have to get you the operating temperature. For luminaires intended for hazardous location, you have to have the T rating of the fixture. So indicate the maximum operating temperature of this luminaire. So Adam, a T, when you see a T on the fixture, it will tell you the maximum operating temperature of this fixture is 500 degree Fahrenheit. So the operating temperature of that fixture must always be kept below the igniting temperature of the surrounding atmosphere. So when they make fixtures in the classified location, Derek, they put them at T. So if T1, you're going to see, if it says T1, then it can't be used up to this temperature. Otherwise, it will ignite. So you're going to see the temperature rating of them. Here you go. Look at if it says T1, guys, T1, for example, operating temperature of T1, Adam, is 842 degree Fahrenheit. Operating temperature of T3 is 392 Fahrenheit. Operating temperature of T6 is 185 degree Fahrenheit. So if you have a gas that can ignite, that can ignite, at 200, the ignition temperature is 200 for this gas, I can't use any of these. I have to use T6. Because T6, it can't get hotter than 185. And the gas can be ignited at 200, so I am below the ignition temperature of that gas. Any question, guys, about the T rated of lighting fixture, the T rated of lighting fixture? So Karen, that's how they pick a lighting fixture in a class 1 or class 2 location. Class 1, class 2, or 3 locations. You can see the higher the number, Adam, for T's, the lower the temperature. So the lower the temperature, meaning that fixture doesn't really get hot at all. It doesn't ignite the surrounding. Any comments, guys, about the T rated of these fixtures? T rated. You're going to hear them all the time. T rated. Okay, when you have luminaires, when you have a luminaire in class 1 div 1, guys, location, if it goes more than 12 inches, you either have to support it with explosion-proof flexible couplings, they call it, with explosion-proof box, or you have to have the brackets. Can you guys see that brackets that go in there? The only thing that you don't need to support is the last 12 inches. Can you guys see that? The last 12 inches, you don't need to allow it 12 inches. So if you have a pendant, they call it pendant luminaire. You can either have a conduit like this, but you have to support the conduit, or you can have a conduit or a cable, and you can have an explosion-proof flexible cord to hold it. And look at the fixture. The fixture, guys, are explosion-proof fixtures. Explosion-proof fixtures. Explosion-proof fixtures. That's so when Derek, when you start working on aircraft hangars or gas stations or commercial garages, always pay attention to the type of fixtures and the type of equipment you install. That's all I want you guys to. It's not just, it's put EMT and move on. MC cable, move on. No. You're talking about rigid, threaded. Everything is explosion-proof, rigid, threaded equipment with a lot of requirements. Motor controllers. Motor controllers, guys, they're using, in this example, manual starters or auto starters used to control your AC or DC motors. They can be auto, like I said, or it can be semi-auto or manual. Require use of pilot devices and magnetic starters and contacts. We talked about this one before. Must be contained. The most important thing hazard-wise is you always have to put them in explosion-proof. So your magnetic starter that we talked about, guys, that costs you $100 now, all of a sudden it becomes $1,000 because of the enclosure that you have to put in. Very, very expensive piece of equipment. Very expensive piece of equipment. Flexible cords and receptacles must comply with the following. If you have cords and receptacles, they have to be extra hard usage, made and explosion proof. contains separate grounding conductor, your flexible cords, properly connected to the terminals. They have to have a proper connection so you don't put stress in the connectors. Be supported by the clamps in a manner that does not transfer the tension into the terminals. So as you can see right here, guys, as you put your cable in here, you don't want the connection. There's some connection here. You don't want the weight of the whole system to be to transfer into the connection and arc and spark. So no transfer. So the extra hard uses, extra ground terminals. They have to have some clamps to support the flexible cord so it doesn't transfer the tension into the terminals. And also you have to seal you have to provide a seal so the gases or the vapors or the dust cannot transfer through the cable or through the flexible cords. So they have a seal on them. Any comments, guys? Any questions? No problem. You can use them in a class 1 div 2 location, but they have to have a special requirement for them. Okay, so the rest of them, guys, are 4 classified locations. The first one is commercial garages where they fix your cars, aircraft hangars where you fix and store aircrafts, gasoline dispensers, your gas stations, and spray and dipping process. Do you guys remember when we went to, where did we go? To Commons? Did you see where they were dipping all these painting and dipping them in paint and coming and moving them into the oven? That's hazardous location, spray area. That's dust. Class 1 and class 2. There could be dust and gas in them. So these 4 locations, and the CIII book guys have 5-6 locations that are classified as hazardous location. Aircraft hangars, garages where they fix your cars, aircraft hangars, gasoline, gas stations, spray and dipping areas. Okay, here's the commercial garage. So Adam, they're doing fixing your car right here, and they don't use pits because of safety anymore. Remember when they used to drive your car over a pit? Some places still have them, and they call, instead of lifting them, they go underneath and fix it. If you have a pit like this in a garage, this is a class, that pit here is a class 1, div 1, class 1, div 1. 18 inches above the ground, this area here above the ground is called class 1, div 2 location. Who cares? If you're to put a wiring method, guys, there, it's going to be an explosion proof boxes. So in a commercial garage, when you design a system, Derek, you have to make sure that your system is above in this area. And they have requirement for the light that you put here. So your light has to be enclosed so it doesn't drop and ignite the surrounding if it accidentally falls. But in the garage, guys, 18 inches above the floor of a garage in all the direction inside that garage where they fix the car is called class 1 div 2 location. So you're going to see most of the people, guys, they put the receptacles higher than 18 inches. Otherwise, you have to have an explosion-proof receptacles. Okay, so that's your garage, and you have to separate the offices with there's separation between the office and where they fix the cars. And an aircraft hangar is the same thing, guys. There's jet fuel there. Jet fuel is very flammable. Any pit like this will be class 1, div 2, div 1, the highest. And then right around the aircraft, you see 5 feet in every direction around the engines of the aircraft, and up to 5 feet above the ground here, in all the direction of that aircraft and the wings and what's not, is classified as a class 1 div 2. Class 1 div 2. Who cares? Anything that enters this place have to be explosion proof. So when you design a system for aircraft hangars, you worked in the airport, your equipment have to clear all your fixtures. Here's my hangar here. You're going to put your fixture right here. That fixture, by the way, have to be enclosed, because if it falls here and there's spill in jet fuel, bam, you got yourself an explosion. So they have to be special type of fixture, not explosion proof, but enclosed. And when you put all your equipment, guys, you have to typically put them higher, your receptacles, so they don't have to be explosion proof. So class 1 div 2. Any comments, guys? Any questions? You work at I don't think, Derek, you don't go to the aircraft hangars. You probably worked in the terminals. Terminals no hazardous location. In aircraft hangars, that's where they put aircraft, and they have jet fuel, very flammable, class 1 location. So you don't want to ignite that aircraft. Okay, same thing for underground gasoline tank. If you have an underground gasoline tank, guys, look at this. The first 3 feet around the vent, remember they have to vent them. That area here is called class 1 div 1. And then from here to here, the next 5 feet, which is basically another circle around there, this area here, that area, this is class 1 div 2. So meaning when you put your equipment, avoid putting any equipment 5 feet around that vent because it's classified area. Same thing, guys, here, 18 inches, 10 feet away from the vent. This area here is a class 1 div 2. Inside the tank is a class 1 div 1. Can't put anything inside the tank other than intrinsically safe system. That's a D-Day, right? That's tank, underground tank. Does that make sense, guys? So knowing that 18 inches, can you guys see that 18 inches right above? So when you put system, avoid putting anything above the area because it has to be rigid, threaded, expensive. So that's your equipment. Gas station. You guys go to the gas stations all the time. If you have a pit in a gas station, typically you don't, but if you have a pit, your pit is a class 1 div 1, the worst of the worst. Because the gas will accumulate there, and if it ignites, you got yourself a bomb. Okay. If you don't, then 20 feet, 18, can you guess it's 18 inches, and up to 20 feet away from the pump, up to 20 feet, in every direction from the pump, 18 feet. This is class 1 div 2. So when they do the gas station, Aaron, they use rigid, threaded metal conduits and coming all over into the gas pump. Inside the pump itself, right here, if you enter the pump, it's class 1 div 1, the worst of the worst. Around the pump in all directions, up to 80 inches, it's called class 1 div 2. So avoid putting anything around the pump electrical, or either have to be intrinsically safe system or explosion proof. Any comments, guys? Any questions? When you put your light above the gas stations here, you can see that they all have to be have to be enclosed. So if the bulb is to fall or break or explode, right? You see on the gas station, they have a globe in them. If they're to explode, are they going to go all the way down? No, they're contained. So they have a enclosure. You know, you can't have an open bulbs like these. If that one, this has an enclosure in it, but if you take that cover, if that explodes, it goes where? Down. Down there's a gas station. There's hazardous location. There could be spill here and it could ignite. Can you guys see the thinking when you do in a gas station? In a gas station like this, they also require you to have a push button right here, emergency. So if you walk into a gas station and there's a spill, that button should be not closer than 20 feet, not further than 100 feet. So you run to that button, typically on the gas station, you push it, you shut down the pump or all the pumps in that area. So you stop the spill because before it ignites. Any comments, guys, about these hazardous location? Now, anything you put in a class 1 div 1, it's going to be explosion proof. This is booth. This is a spray booth. Do you guys remember when we went to Cummins and EMI? They have spray booth. Inside the spray booth, inside your spray booth, there could be class 1 or class 2 location, div 1. That's where they're spraying. There could be flammable gases and ignitable dust. Both exist in that area. And there's also the zone. If you hear the word zone, zone 1, guys, is equivalent to a class 1. Zone 2 is equivalent to zone 1 is div 1. Zone 2 is div 2. The other one. And look at this one. This area, guys, here is a class 1 div 2 around the opening, around 3 feet from every opening. Look at this one also here, class 1 or class 2 div 2. They get you all around the openings. Can you guys see that? They want you to clear all these openings up to 10 feet. So any opening, can you guys see the opening? Any opening is classified as class 1 div 2. Inside is class 1 div 1. Does that make sense? Up to 3 feet, in this case up to 5 feet here. Can you guys see 5 feet from every opening? Right here up to 10 feet from the opening. Um, 3 feet from this one. Any comments, guys? Any questions? So you're gonna avoid putting any electrical system in these areas, or if you put them, Derek, they have to be explosion-proof equipment or dust ignition-proof equipment if it's dust. That's your spray area. Dipping area. This is exactly what we did when we went to comments. Do you guys remember all these pieces of the generator? They were moving in a conveyor and going inside the tank to be dipped. You guys remember that? They were getting inside the tank. This area is class 1, div 1. We have class 1, div 2, or class 1, div 1. Guys, when you paint, you have both hazards. You have dust and you have also flammable gases. So you can see the area 5 feet around it and 8 feet, up to 5 feet here, up to 8 feet here. So here's these areas. All these are class 1, div 1. 3 feet off the ground right here, up to 20 feet away. Any pit is a class 1, div 1. So who cares? When you design dipping, painting, spray, and dipping process, Adam, you are to take into consideration this. You have a lot of coordination to do with your chemical engineers or whoever designing it to avoid putting electrical equipment in the places where it could ignite the whole place. Do you guys see the gravity of these? You have flammable stuff. You put an ignition there and you get yourself a big fire. So open spray areas, the same thing in the open spray areas, guys. They get you clearances of 20 feet. Look at that. That will be class 1, div 1, div 2, and up to 5 feet from that opening is class 1, div 1. I don't know if you guys can see that right here. Right here. Could be class 1 or class 2 because both hazards exist. Same thing here. Class 1 and class 2. The first 5 feet is a class 1 or 2 div 1. The second 20 feet from it is a class 1, class 2 div 2. Any comments, guys, about these areas? So Derek, I know there's a lot of information. If you ever get into places where have flammable gases or vapor or dust, flag. Let's go see what that's a special wiring system. Unlike we're done with here. I mean, you can use EMT, anything you want here, any approved method. What's in it for you guys when you do estimating? It's going to be expensive to install the system and maintain the system and troubleshoot the system. Everything is expensive there. Okay, a couple of things about explosion-proof equipment, guys. When you do explosion-proof equipment, when they tie them, guys, together, they bolt them. I'll show you. They're bolted together, so you can't. The mating surface, they call it the mating surface of the explosion-proof boxes, are ground flat to provide a closed fitting. So you can't just go and scratch that mating surface. If you scratch the mating surface, you will alter the characteristic of that surface, and basically you disable it. Screwdrivers, gauges, or deep scratches on them basically will provide exit point to the hot gases, so you don't want to do that. All bolts must be placed and tightened. There's tons of bolts that have to tighten. Seals must be installed between the explosion-proof equipment to prevent pressure piling. There's something called pressure piling, guys. If you have an explosion, Adam, if you have 2 enclosures tied with a pipe, if you have an explosion one and that gas goes into the second one, it will double the amount of pressure in the second one and have a bigger explosion. They call it pressure piling. So summarize, guys, what we did. I hope what you should take out of here is there's a class 1, class 2, and class 3 locations. There's also div 1 and div 2 for each one of them. And there's groups A through F or A through D. And also then they classified the areas. All these are classified areas in the sequence book, so you have to pay special attention. Don't forget that for your instrumentation, you have a really nice circuit that's called intrinsically safe circuit, so you don't have to worry about explosion proof. But that's for instrumentation. Can intrinsically safe circuit, guys, feed a fixture like this? No. That's just for getting a sensor, sensing the pressure and the temperature and what's going on. And that's a big deal. When you have a chemical process, don't you think you want to know what's going on in that process without exploiting it? So that's, I have a couple of pictures I'm just going to go over, and then that's it. We talked about, guys, the seal. Look at how big the explosion proof. I have a couple of pictures to show you. Here's how they do the seal, Adam. First, they do a fiber dam here. If you're an electrician, that's what you do. You put the fiber dam, and then you put the seal. You fill it with seal. You seal it, right? And the seal comes right in here. So the gas now cannot move through this at all. You see how the seal, if you have a gas coming in here, it stops right here. Can't go anywhere. Now you minimize the explosions. That's your seal, vertical seal. And remember that you have to have a place to for the water to sieve. If it's horizontal, guys, they have both dams. When they build the system, you guys are not electricians, but what they do is they dam it here, and then they put the seal. They seal it. So if there's a gas coming in here or gas coming in here, in either direction, it doesn't stops. Who cares? That will guarantee you guys that the gas is not going to be channeled through the conduits from point A to point B and creating an explosion. So it's a big deal, the seal. Look at the lighting fixture, Karen, that they do. They have globes in a globe in a globe. So that's how they contain it, guys. We have an outer clear explosion-proof globe, then an inner colored globe inside. Can you see that? Lamp inside it, an adapter for color. So the temperature, guys, right here, your temperatures, because they have two globes, the temperature would be not a whole lot of temperature in there because they contain it. And it can contain an explosion proof inside this fixture. What's the drawback? Expensive. Here's another fluorescent explosion proof. That's the one that you guys used in our project. Explosion proof fixtures. We talked about, guys, supporting the fixtures with an explosion proof box and flexible couplings or brackets. Temperature rating, full load, and heater table rating. So you have to adjust. You have to do some adjustment, guys, for your full load motor current and heaters rating because of the hazardous location. If you are to put equipment, guys, in a hazardous location, look what happened. The switch, this is explosion-proof receptacle. 10 times more expensive than the receptacle that you can have here. And the equipment, guys, extra hard usage cord when you plug it in. This equipment also here have to be explosion-proof, so it can handle an explosion. You don't want anything to have arc and spark and ignite the area. We talked about, guys, the pit in a commercial garage, and we said it's class 1 div 1, up to 18 inches. Up to 18 inches, Derek, right here. I don't know if you guys can see right here, up to 18 inches, class 1 div 2. Aircraft hangars, around the aircraft hangar, 5 feet. Can you guys see 5 feet from the wings all the way 5 feet above the wing, 5 feet above the engine, in all directions, class 1 div 1. And the pit is a class 1 div 2. We talk about the tank, inside the tank, class 1 div 1, and then it goes the first circle, the 3 feet, class 1 div 1. The second one, which is the second 3 feet, is class 1 div 2. All your vents. Talk about the gas station, guys, pits and the surroundings. The booth. The booth, inside the booth is class 1 div 1 or div 2. What else? The dipping. Okay, so here's one thing. Metal surface, screwdriver gouges here. If you make a hole here, can you see that? Little hole, that will screw up the whole system. So you make sure that you don't damage, Adam, when you install these, you do not damage the surfaces when you install them. This is called pressure piling, guys. If you have an explosion in this one here, and it seeps into this one, the second enclosure will have double, triple the pressure that the first enclosure had if you channel them. Pressure calculation. So what does that mean? If you have an explosion in this one and you have a pipe here, and you pipe that gas into the second one, you create a bigger, more destructive explosion here. So what do you think they do here? They seal it. So that's where they seal between the cold pressure piling. Do you see that, Anna? Then you can seal it right here. Now if you have an explosion here, nothing will happen in this enclosure. That's why they seal between all these enclosure and explosion proof. Pressure piling, they call it. Threaded, look at that, guys. You have to have a threaded system. You cannot use EMT, for example, in class 1, div 1, and div 2 location. It's all threaded. Cables, guys, are threaded and sealed that they use. So everything is, they allow the system, if you have an explosion, to release the gas. If you look at that, if you have an explosion inside it, there's a lot of threads, guys, that the gas will go right through the threads. At the time atom it enters here, the gas will be the temperature will be very low that it would not ignite the surrounding. So that's how they control the vent of these equipments. Look at what they do. These are junction boxes. These are junction boxes, guys. Unlike the junction boxes like I use right here, all threaded. You guys wired a few of them. Threaded junction boxes that you can use, very expensive. Seals, look at how the seals look. This is the plug. You take the plug, you put the damp, and you put the seal in it. Explosion-proof seal in these areas. Same thing, guys. Here's the weep. I don't know if you guys can see that right here. The plugs and the weep where you can allow it to drain. There you go. Here's the drainer. I don't know if you guys can see right at the bottom here. You seal at the top, and this will allow the accumulated moisture to collect and seep out of that fixture, so it doesn't damage. This is, I think, a circuit breaker. Look at how big. This is a circuit breaker. Can you guys see? That's an explosion-proof circuit breaker. You're looking at 10 times, 20 times more expensive. That's big boy, circuit breaker. So look at the panel. The panel, lots of bolts. So if there's an explosion, it holds that explosion. Very expensive, very bulky equipment. Here's another example of it, guys. You can see how it looks like an explosion-proof pieces of equipment. So I hope I'm driving to you guys the importance of, so a good design, Adam, will remove that panel from an explosion-proof. You wouldn't put the panel in an explosion-proof area. But sometimes you have to. Here's another other application, guys, where you have enclosed fixture that can use in other application, explosion-proof fixtures. Explosion-proof flexible cord that you can use in an explosion-proof area. These are, I think, starters. Looks like starters, explosion-proof starters. On-off starter. So you can see all the equipment, start button. All these are very, very expensive piece of equipment, guys, that you put in these areas. A circuit breaker, I believe this is, or a controller. This is a controller. Look how they put them, guys, inside that big box. It can handle the whole explosion as a controller. This is a plug. So when you plug it, guys, you can't connect. So first you plug it, then you connect. That's how it's made. So it doesn't arc and spark, explosion proof. So everything is very robust. Here's your plug in an explosion proof location. We talked about the groups, guys, and the gases. We've said group 1 through group E is gases, F through G through D is dust. Temperature, we talked about the temperature rating. So that's basically what I would like to talk, guys, about classified location. Any comments, any questions? If you're an electrician, you guys have done probably a couple of examples. We teach our apprentices how to wire in these areas. Very expensive, very dangerous working with these. You ignite. There was a friend of mine sent me an explosion in the country of Jordan. Natural gas. You're not going to believe if you watch it. It's just that natural gas. It's a big wave of fire spread. It's a plant, natural gas plant. A big explosion there, and the technicians are standing there watching the equipment. All of a sudden, literally a big wave of fire sweeps through the whole plant, through the security camera coming. Unreal. And everybody, you can't do anything. Just run, basically. You can imagine what a natural gas explosion would do in a plant. I probably have seen a few of these. So our job, guys, as designers and engineers, we have no control over how they handle this equipment. That's not our job. Is to starve the fire from the ignition source. That's what we do. Starve it from its ignition source. How do we starve it from ignition source? We put our equipment in explosion-proof equipment. So if it arcs and sparks, it's contained. That's all. Because I have no control how they handle they have a whole industry handling the gas and natural gas, but with coordination with them, we put special equipment there that cannot ignite provide a starting an ignition source for these gases and dust or fibers. The NEC code book is very, very strict about it, guys. We have, my God, almost 12 articles talk about different location, special location from aircraft hangars, how do you wire there, into garages, into the type of equipment that you can install. Almost all of them require threaded rigid, which is the most robust wiring method that we use. Any comments, gentlemen? Any questions? Comments, questions? That's all I have for you guys. So my hoping is we can wrap up. I don't want to go another class today coming from the holidays, but let's wrap the project, shall we? Thank you. Make sure you guys do your homework. Please, please, please do homework. I'm going to check your homework one time and give you credit for it. Please, please. It's easy, 10 points. So, thank you.